Hello everyone. Today in this video we are going to learn on section 13.2, that is on distributed systems, that comes under topic 13, enabling technologies. 13.1 was on virtualization, and you can see the link to that video on the screen. So let's go to. Okay, so as per the Edexcel A-level IT spec, under section 13.2, distributed systems, you need to know what a distributed system is, understand the concept of and the need for distributed system, and understand the issues associated with the distributed systems such as failures, concurrency, replication, and performance. Right. So, what's meant by a distributed system? A distributed system is a system whose components are located on different network computers which communicate and coordinate their actions by passing messages to one another from any system. A good example of a distributed system is a social media platform like Facebook. Facebook operates as a distributed system. Facebook's infrastructure consists of numerous servers distributed across different locations worldwide, and these servers handle various tasks such as storing user data, serving web pages, processing user requests, and running complex algorithms for features like news feed ranking and friend suggestions. Right. Uh, and there are various types of distributed systems. Networks. The 1970s saw the invention of Ethernet and LAN, the local area network, which enabled computers to connect in the same area. Peer-to-peer networks and email and internet continue to be the biggest example of a distributed system. And then we have telecommunication networks. Telephone and cellular networks are like other examples of peer-to-peer networks, and telephone networks started as an early example of a distributed communication, and cellular networks are also a form of a distributed communication system. So with the implementation of voice over internet, we also called as VoIP, communication systems, they grew more complex and distributed communication systems. And then we have real-time systems. Time systems are not limited to specific industries. These systems can be used and seen throughout the world. Uh, in airline industry, and then logistics, financial trading like stock markets, and then massively multiplayer online games and e-commerce industries. The focus in such systems is on the correspondence and processing of information with the need to convey data promptly to a large number of users who have an expressed interest in such data. And then we have distributed database systems. Database is spread across, like it's spread across, it's spread out like across numerous servers or like different regions. So data can be replicated across several platforms. A distributed database system can be either homogeneous or heterogeneous in nature. A homogeneous distributed database uses the same database management system, and if it is heterogeneous, it's like different types of database systems. And then we have distributed artificial intelligence. Distributed artificial intelligence is like one of the many approaches of artificial intelligence that is used for learning and complex learning algorithms, large scale systems, and decision making. So it requires a large set of computational data points located in various locations. And then we have distributed ledgers. Distributed ledgers, such as blockchain, are a type of distributed system that allows multiple parties to have a shared tamper-proof record of transactions. Distributed ledgers can be used for a variety of applications such as digital currencies and supply chain management. And then we have IoT, Internet of Things. The Internet of Things is a type of distributed system that connects devices such as sensors, cameras, and appliances to the internet. IoT devices collect and transmit data to cloud based systems for uh, processing and analysis. IoT is often used in applications such as smart home automation, smart cities, and then factories or like industry automation. And then we have distributed file systems. Distributed file system is a type of distributed system that allows files to be stored and accessed across multiple nodes. Distributed file system provide a transparent view of the files to the user, regardless of like where the files are stored and located. Right. So here are some real world examples of distributed systems. uh, in video rendering systems. Imagine you have a really fancy computer, but rendering a video takes like forever. And instead of waiting, you can distribute the task among multiple computers. Like each computer works in a part of the video simultaneously, making the process much faster. And then we also the good example is like scientific computing. Scientists like often they need to process large amounts of data for their research, and so distributed systems allow them to divide the workload among many computers, speeding up the complex calculations or simulations. And then we also see distributed systems in airline and hotel reservation systems. Like when you book a flight or a hotel room online, your request goes to a distributed systems. Different servers can handle different parts of the process, such as checking availability of rooms or the flight seat, and then processing the payments and issuing the tickets. So all working together to provide a seamless booking experience. And then another example is the cryptocurrency processors like Bitcoin. In cryptocurrencies like Bitcoin, transactions are like verified and recorded on a decentralized network of computers called nodes. So each node stores a copy of the blockchain and works together to ensure the integrity and security of the system without the need for a central authority. And then we have the P2P file sharing like BitTorrent. BitTorrent allows users to share files. Like I know a lot of people use BitTorrent to download movies. So BitTorrent allows users to share files directly with each other without relying on a central server. So instead, the file is broken into smaller pieces, and each user downloads and uploads pieces to and from the users, creating a distributed network for file sharing. And then we have multiplayer video games. In online multiplayer games, the game world and interactions between players are often managed by distributed systems. So different servers handle different aspects of the game, such as player movements, actions, and communication. Like so, it ensures smooth gameplay for like all the game participants. And then we have e-learning applications. uh, Platforms like platforms that are like for online learning often use distributed systems to handle the large number of students accessing courses, videos, quizzes, and assignments like other content simultaneously. So content delivery networks distribute course materials across multiple servers to ensure like fast and reliable access for the students who are learning distance learning worldwide. And then we have distributed supply chains like Amazon. Companies like Amazon manage complex supply chains involving multiple warehouses, multiple suppliers, multiple distribution centers. So distributed systems will help coordinate inventory management, order processing, and shipping logistics across different locations. So why do we need distributed systems? Because the monolithic systems, like where all the resources are located in single location, so it's limited to availability. So in such situations, when a disaster or a breakdown happens in that location, the system is not able to function and we cannot access. But if that system is distributed, that issue is not there. Like or like when we store data in distributed systems, we can access data even if there's a failure in one location. So that's why companies like Amazon, Facebook, Google, like they have data centers distributed in different continents, different countries. So they get the advantage of better availability and durability using different location advantage and having distributed systems. Right. And also when we design distributed systems, it's designed in a way that we can scale it easily, either scale up or scale down. So meaning increasing or decreasing resources like memory, servers, and etc. Also with the scaling, we get the benefit of like having better performance and better efficiency, and also the correct usage of the IT resources. Right. So we learned just now why we need distributed systems, and we learned we need distributed systems for better availability, better scalability, better efficiency, and better durability. So we will see how it provides uh, scaling. So scaling is the ability of a system, application, or infrastructure to handle an increasing amount of data, users, or load without the compromising the performance or stability. So, like essentially, it's about accommodating growth without breaking the current system. So, there are three ways we can grow or scale a distributed system. We can scale it horizontally or vertically, or having the hybrid scalability. Right. So, horizontal scalability is also known as the scale out, refers to the ability to add more instances of the same resources to a cloud environment. If you take an example, you can add more servers to your environment if you need more computing power. So, this type of scalability is often used to handle large scale web traffic or data processing needs. One of the primary benefits of horizontal scalability is that it allows you to achieve greater processing power and performance by distributing the workloads across multiple resources. And then we have the second type is the vertical scalability. Uh, Vertical scalability, it's also known as scale up. It refers to the ability to add more resources to an existing instance. For an example, if you need more computing power, you can add CPU, RAM, or storage to an existing server. So, this type of scalability often used for applications that require more processing power than can be handled by a single instance. So, one of the primary benefits of vertical scalability is that it allows you to optimize your existing resources, which can help you save cost and reduce waste. Whereas in horizontal scalability, you add more servers. It's called scale out, right? So in the third type is hybrid scalability. Hybrid scalability, it's known as diagonal scaling, combines both horizontal and vertical scalability to provide a flexible and scalable cloud environment. So this type of scalability allows you to add more instances or resources as needed, while also optimizing your existing resources to achieve maximum efficiency. So, hybrid scalability is often used for complex applications that require combinations of processing power and efficiency and all of that. So, when we are scaling, what are the benefits we get if we grow our system in cloud? Okay, so one major benefit is the cost saving. One of the primary benefits of cloud scalability is that it can help you reduce cost by only paying for the resources that you need. You also can avoid overspending on unnecessary hardware or infrastructure. And apart from that, cloud scalability allows you to optimize your resources, which can help you save money or on maintenance and also on energy cost. And then we get the benefit, other benefit is improved performance. Cloud scalability allows you to scale up or down resources in real time, which means you can respond quickly to changing computing power or bandwidth demands. So this can help you avoid bottlenecks and ensure that your applications and services are always performing at their best. When you need, you can scale up. When you don't want, when there's no peak, you can scale down easily. And the third benefit is the flexibility and agility. Cloud scalability allows you to respond quickly to changing business needs. It can help you stay ahead of the competition, and in addition, cloud scalability can help you adapt to new market conditions or customer demands, like when there are seasonal demands or something like that, you can scale up, or when it's not the off season, you can scale down likewise. And then the other benefit is the improved availability and also the reliability. So cloud scalability allows you to distribute workloads across multiple resources, so it can help you avoid any downtime and good performance, so that your applications or the services are always available with and performing at the expected standard levels. And then we have the benefit of enhanced security. So the cloud scalability allows you to implement security measures such as load balancing, firewalls, and other security features. So it can help you protect your data and applications in the right. So, distributed systems have a lot of advantages that make their use popular. A few important ones include improved performance and scalability. Distributed systems can handle large amounts of data and high user loads by distributing the workload across multiple machines. For an example, a distributed web server can handle more concurrent user requests by distributing them across multiple servers. And then we also get the increased fault tolerance, because distributed systems are more resilient to failures as they can continue functioning even if individual component is failed. If you take an example, distributed database can replicate data across multiple nodes, so it ensures data availability even if some nodes go offline. And then we get the enhanced reliability. Distributed systems can provide reliable services by replicating data and services across multiple nodes. For an example, a distributed file system can store multiple copies of files on different machines, so it reduces the risk of a data loss. And then we also get the geographic flexibility. Distributed systems allow for data and services to be located in different geographical locations. So it enables organizations to have a global presence and serves users in different regions. Uh, for an example, a distributed content delivery network can cache and serve content from servers located in various countries. So it reduces the latency for the users. And then we have the cost effectiveness as well. So they have a high cost of implementation in distributed systems, but in the long run it can be cost effective because they can utilize commodity hardware and distribute the workload across multiple machines, so it reduces the need for expensive high-end hardware that can lead to cost saving. For an example, a distributed company system can utilize a cluster of low-cost machines instead of a single expensive supercomputer, and you have the flexibility to scale up and scale down whenever you need. And then we have the benefit of data sharing. Distributed systems enables a component to share data easily with other components of the system. So this is possible because in distributed systems, nodes are interconnected for collaboration purposes. And then another benefit is time effective. In today's world, like, time is an important constraint for business personnel and users alike. So distributed systems provide a low latency rate. For an example, consider a user who uses the internet and loads a website. The system makes sure that the node located closer to the user is used to perform the loading task to save time. So while we have a lot of benefits, there are some issues occur while using distributed systems. So like this sort of advantages. So let's go through important ones here. Right. Uh, One major negative thing is the complexity. So distributed systems are more complex and centralized systems than the centralized systems due to the need for coordination and communication between multiple nodes. Uh, in simple terms, like distributed systems, database systems, to ensure the data consistency across multiple nodes, it's challenging. And then increased cost of setup, like building and maintaining a distributed system, can be more expensive compared to a centralized system. For an example, deploying and managing multiple servers in a distributed cloud computing environment can incur higher cost than using a single server in a traditional data center. And then we also have security vulnerabilities. Distributed systems can be more susceptible to security vulnerabilities due to the increased attack surface and the need to secure communication between nodes. So ensuring that messages are like exchanged between nodes remain confidential and intact in a distributed messaging system like could be difficult. And then we also have the difficulty in debugging and troubleshooting. So identifying and resolving issues in a distributed system can be more difficult compared to a centralized system. For an example, diagnosing performance problems in a distributed application can require like analyzing logs and metrics from multiple nodes, whereas in traditional system it's like centralized and it's easy to debug and find the problems. And then we also have the data loss, so like overloading due to network dependencies. There can be instances when the data sent from one node to another node can be lost midway in its journey from the source node to the destination node. So this results in some like important messages being lost. So it could be detrimental to the business world. And then we also see data inconsistency due to replication. Distributed systems replication in the sense copying, having the same data in another place. So distributed system mostly replicate the services and databases to avoid single point of failure. So as well as to scale under high usage. So this brings in challenging data consistency since it's not a single database but more than one database that needs to replicate. So any change, removal, or addition of data, right? So these are some advantages and disadvantages of having a distributed system. So now let's see some practice questions on distributed systems. They may ask what are the advantages of a distributed system, or else may ask why we need to use distributed system. So in such question you can justify saying distributed systems offer several advantages. Firstly, they provide improved reliability and fault tolerance. With distributed systems, if one component fails, the system can continue to operate using other available components. And additionally, distributed systems can handle high volumes of data and traffic, allowing for scalability. They also offer better performance by distributing the workload across multiple machines, so which can lead to faster processing times. And also, you can say distributed systems provide increased flexibility and accessibility as they can be accessed from anywhere in the world. Something so you can have that information and write a good answer. And second question is what are the advantages of a distributed system? So one of the main challenges is the complexity of designing and managing such systems. Coordinating and synchronizing different components can be difficult, and ensuring consistency across all nodes can be complex task. And another disadvantage is the increased network overhead, and communication between nodes in a distributed system require network communication, so which can introduce latency and additional cost. And additionally, the security can be a concern in distributed systems as the distributed nature can make it more vulnerable to attacks and breaches. And also, you can say debugging and troubleshooting can be more challenging in distributed systems due to the increased complexity and the need to identify in which node and rectify the issues. How does the distributed system improve reliability? Distributed systems make things more reliable by being all about fault tolerance. If one piece breaks, the system can keep going using the other pieces that are still working. So, when you spread out the workload across a bunch of machines, the system can handle problems way better. Plus, they can copy the data in different places. So, even if something goes wrong, the info is still around. So, it's like having backups for your backups. So the system can keep uh, chugging along even if some parts are not available. How does the distributed system handle scalability? Well, these systems are all about spreading the network across a lot of machines. So when more resources are needed, you can just add more machines to the mix. Think of it like adding more lanes to a highway when traffic gets heavy. So it helps keep things moving smoothly. And because of the system is spread out, it can handle a ton of traffic and more users without breaking a sweat. So by dividing up the workload, no single machine gets overloaded, which means the system can keep up with the demand without slowing down nor messing up. So basically, it's all about making sure the system can grow and adapt as needed to keep everything running smoothly for the business or for the users. So with this question, I'm wrapping up the lesson on section uh, distributed systems. Right. So thank you and stay tuned for the next lesson. And yeah, let's meet again.